So this is our thought experiment, which is all well and good, but that's just what it is. It is a thought experiment. In reality, well, keep these equations in mind. In reality, we have to do magnetic field due to a current flow at a point. Okay, so I'm going to try to draw this. Suppose I want to know at point P, which is at point R, how much this moved. Think this is fancy R. Imagine this is angle theta. And this thingy moved from here to here. And imagine this moved a distance dl. There's a current I that's going from here to here. So consider that the current element are represented by dq that moves from point A to point B. And it does it moving at velocity v. So may I write that the charge element dq moves a distance or displacement dl in time dt. Then can I write the velocity of dq is dl over dt? May I write this as v equals dl over dt? May I multiply the both sides with dq? Will it make any difference? So may I write this as what is dq over dt?
A current.
Very good. May I rewrite this then as v dq equal dl times I for current? Woohoo, okay, well that's great. May I also remember this equation? I'm going to call this the cat equation. So my kitty cat equation, I'm going to rewrite this again as dv for the small element mu naught over 4 pi dq v cross r divided by r cubed May I rewrite this as mu naught over 4 pi dq v cross r hat divided by r squared? Understand the difference between cube and squared? Okay, now in this equation, may I put this whole thing here to make this equation or to find the complete B field at point P, we integrate. Oh, this should be a vector. Sorry, guys, I forgot vector signs. Or equivalently, ta-da! This could also be written as mu naught over 4 pi I dl sine of theta over, oh, now in this case, it won't be that fancy looking r, it'll just be the r squared. Just like we saw here. Remember how we went from here to here? It's the same thing. That orange one. It's just working its way backwards. And you have just developed what is the fancy word for a law that people find very difficult to memorize and understand. Isn't that magical? Like you can just see the progression and all, like go back and appreciate what you've done. All we did was we went through a thought experiment and we wrote a bunch of stuff and then we just wrote it together. That's it. And then it became this scary looking equation. But all it is a thought experiment with one moving charge. I really like doing that. This exercise has been good. This is a fun exercise to do.